Hi everyone, welcome to Lecture 23 on Basic Inorganic Chemistry. My name is Dr. Teresa Chimambam. Today we will cover strength of acids and we will look at how strong and weak acids and bases dissociate. When a strong acid, such as HCl, dissociates, it separates completely into its constituent ions. So when HCl dissociates, it will separate into its separate ions, which are H plus and Cl minus. So because HCl is a strong acid, it will dissociate completely into its constituent ions. So this is HCl. We have 3 molecules of HCl. When you add this acid to water, remember you always add acid to water and not the other way around. So when you add HCl to water, it will dissociate completely and it will have 3 H plus ions and 3 Cl minus ions. So there will be complete ionization of HCl in water. So it will dissociate completely into its constituent ions. So you have your HCl, there will be complete dissociation into its separate ions. So this is applicable to all strong acids, not only HCl. It is also applicable to other strong acids such as sulfuric acid, H2SO4, or nitric acid, HNO3. When a weak acid, such as acetic acid, dissociates, it does not dissociate completely in solution. So weak acids do not dissociate completely in water. So acetic acid is CH3COOH, but if we represent CH3COOH by HAC, we will have HAC, 3 molecules of acetic acid, and when we add it to water, only one of these 3 acetic acid molecules will dissociate. So you see H plus, AC minus. These 2 molecules of acetic acid are still bound together. So in this case, we say that there is partial ionization. So weak acids do not dissociate completely in water. And example is acetic acid, as you can see here. 3 molecules of acetic acid. When you add it to water, only 1 molecule will separate into its constituent ions. The other 2 molecules remain the same. So, strong acids dissociates completely into its constituent ions, while weak acid do not dissociate totally in water. So this is what differentiates between a strong acid and a weak acid. So the ability to ionize completely in water is what makes one acid stronger and the other one is weaker. So stronger acids, such as HCl, they have complete ionization, while weak acids, such as acetic acid, has partial ionization in water. So, a strong acid is one that fully dissociates and the reaction goes to completion. Example is HCl plus water to give hydronium ion plus Cl minus. So this is a strong acid. What it means is that it will fully dissociate and the reaction goes to completion, as we have seen here. But not all acids dissociate completely. weak acids do not fully dissociate into their constituent ions. Example is acetic acid plus water. It will form acetate ion plus hydronium ion. So this is an example of a weak acid that does not fully dissociate into its constituent ions. So this reaction is an equilibrium reaction. A chemical reaction is in equilibrium when the concentrations of the reactants, acetic acid and water, and the products, acetate ion and hydronium ion, are constant. So a chemical reaction is in equilibrium when the concentrations of the reactants and products are constant. Their ratio does not vary. The forward and reverse reactions occur at equal rates. So this is the forward reaction and this is the reverse reaction. So it goes both ways. Forward reaction, reverse reaction. So now we look at strong and weak base dissociation. We look at how strong and weak bases dissociate. We have already looked at how strong and weak acids dissociate. Now we look at how strong and weak bases dissociate. When a strong base, such as sodium hydroxide, dissociates, it separates fully into its constituent ions. So just like a strong acid, such as HCl, when a strong base dissociates, it separates fully into its constituent ions. So this is sodium hydroxide. When it dissociates, it will separate fully into its constituent ions, which are Na plus and OH minus. So this is an example of a strong base that dissociates and separates fully into its constituent ions. So strong acids dissociate completely in water. So here we have 3 molecules of sodium hydroxide, and in the presence of water, there is complete ionization. You can see 3Na plus because we have 3 molecules of NaOH and 3OH minus. So there is complete ionization. And this happens because sodium hydroxide is a strong base. So when it dissociates, it will separate fully into its constituent ions, which are Na plus and OH minus. So this is only possible for strong bases. Weak bases, such as ammonia, dissociates partially. So their dissociation is not complete. They only dissociate partially. Only strong bases dissociate fully into their constituent ions. Weak bases do not dissociate completely into their constituent ions. So we have seen that when we dissolve most ionic substances in water, they dissociate into their individual ions. Examples are sodium chloride plus water. When sodium chloride is dissolved in water, it will dissociate into its individual ions, which are Cl- and Na+. Also for HCl, it will dissociate into its individual ions, which are Cl- and H+. So when HCl is dissolved in water, it will form Cl- and H3O+. But most molecules do not dissociate into ions. An example is sucrose. This is an example of a molecule that does not dissociate into ions. This is the formula for sucrose plus water. It will form two glucose molecules. So it does not dissociate into its individual ions. But in the case of sodium chloride and HCl, when they are dissolved in water, they dissociate into their individual ions. Now we look at oxy acids. What is an oxy acid? An oxy acid is an acid that contains oxygen, hydrogen, and at least one other element. It must also contain an acidic hydrogen. So an oxy acid must have oxygen, it must have an acidic hydrogen, and it must have at least one other element. An example of an oxy acid is acetic acid. You can see it has oxygen, it has acidic hydrogen that is attached to an electronegative atom, and it has another element, carbon. So it qualifies to be an oxy acid. So an oxy acid contains oxygen, an acidic hydrogen, and at least one other element. So in the case of acetic acid, that acidic hydrogen is this hydrogen. This is the oxygen. It has two oxygen atoms, and it also has one other element, which is carbon. So this is a good example of an oxy acid. And remember, an oxy acid contains oxygen, an acidic hydrogen, and at least one other element. Right, so this is where I'm going to end for today's lecture. Please like this video and subscribe, and I will see you in the next lecture.